You know that specific low-grade misery of the failed search? I'm talking about that moment where you type in a question, something complex, maybe a bit nuanced, something that actually matters to you, and the search engine just punts.
It completely gives up on the logic.
Exactly. It gives you a result that is technically related to one of the words you used, but it doesn't actually answer the question. It's like asking, what's the best way to bake a cake without eggs? And getting a Wikipedia article on the history of chickens.
That is the classic single hop failure. You are asking for a connection between two concepts or solution to a problem, and the system just gives you a noun, gives you a definition.
Right. And then what happens? You, the human, have to pick up the slack. You have to read the article, find a clue, open a new tab, search for that clue, read another article, realize that was a dead end, go back, find a different clue. You become the processor. You are doing the actual intelligence work, and the search engine is just a dumb filing cabinet.
Which is annoying for a human. We have limited time, we get frustrated. But for artificial intelligence, specifically for large language models, that single search limitation is a massive structural wall. It is the defining line between a chatbot that can vaguely chat with you and an agent that can actually do work.
Well, today we are looking at a system that claims to smash right through that wall. We are diving into a paper that I honestly think is going to change how we look at AI research. It's titled AutoRAG, Autonomous Retrieval Augmented Generation. And the promise here is pretty wild. It's about moving AI from being a passive reader of search results to an active investigator.
An investigator that knows when it's confused, that's the key.
That is the hook for me. We're talking about an AI that can stop, think, and say, wait, I don't know that yet. Let me go look it up. And if it doesn't find the answer, it doesn't just hallucinate. It looks again. It changes its strategy. It browses.
This comes from a team at the Chinese Academy of Sciences, and they've essentially built a methodology that allows a large language model to browse the web or a database with the same iterative logic a human researcher uses. It's not just about getting better answers, it's about the process of how the machine decides what to read and when to start.
And that is our mission for this deep dive. We aren't just going to look at the results. Spoiler alert, they're good. But we want to pop the hood. We want to understand the methodology. How does this algorithm decide when to search? How does it know when it's found the answer? And how on earth did they train a computer to have that kind of inner monologue?
It's a fascinating look into the future of agentic AI, and it really requires us to rethink what we expect these models to do.
So let's set the stage. To understand why AutoRAG is such a breakthrough, we have to understand the baseline. We hear the term RAG thrown around constantly in this space. Retrieval Augmented Generation. In the simplest terms, that's just giving the AI an open book test, isn't it?
That's the best analogy for it. If you look at a base model, pure ChatGPT, pure Llama, no plugins, it's taking a closed book test. It relies entirely on its training data, which is essentially its memory.
Which cuts off at a certain date.
Exactly. If it didn't memorize the fact during training, or if the fact happened last week, it fails. And because these models are designed to be helpful, they often fail in the worst way possible. They lie. They hallucinate.
The confident liar. Yes, of course, the moon is made of green cheese, specifically cheddar.
Precisely. So RAG was the solution. It stands for Retrieval Augmented Generation. You let the student bring a textbook into the exam. You ask a question. The system searches a database like Wikipedia, grabs the top few paragraphs, and pastes them into the prompt along with your question. The AI reads the paragraphs and answers based on that text.
Which sounds great on paper. It solves the memory problems, it solves the freshness problem. So what's the issue? Why isn't standard RAG enough? Why are we writing new papers about it in 2026?
The problem is that standard RAG is incredibly rigid. It's usually a one-shot deal. It follows a strict pipeline. Retrieve, then read. It grabs documents once based on your initial question, and then it has to answer. It doesn't get a second chance.
So it blindly trusts that the first search was perfect.
Yes. It assumes the librarian, the retrieval system, is infallible. And that creates three massive problems. The first is noise.
Explain noise in this context.
Search engines aren't perfect. We know this. If you ask a question and the retriever brings back 5 documents that share keywords but are totally irrelevant contextually, standard RAG is trapped.
It's like if I asked, how do I fix a flat tire?
Yeah.
And the search engine brought back a history of the Michelin Man and a review of a tire swing.
Exactly. And the AI is forced to write an answer based only on those documents, so it tries to connect the dots that aren't there. It might tell you to fix the tire by swinging on it. It treats the retrieved text as gospel truth, even when it's garbage.
So that's the noise problem.
Yeah.
Can't filter out the junk. What about complexity?
This is the multi-hop problem. This is where standard RAG falls apart completely. Let's take an example from the paper, which is a bit of a brain teaser. Where was the place of death of Anastasia of Serbia's husband?
Okay, let me process that. That's a two-part problem. You need to know who the husband is first.
Right. A human knows that immediately. You think, I don't know who the husband is, so I can't know where he died. Step one, find the husband.
But standard RAG doesn't do step one.
No, standard RAG just takes the whole sentence, where was the place of death of Anastasia of Serbia's husband,
Yeah.
and throws it into a vector database.
And the database sees Anastasia of Serbia and death, and probably returns a biography of Anastasia.
Exactly. It returns a document saying Anastasia was married to Stefan Nemanja. Great, that's a useful fact, but does that document mention where he died?
Probably not. It's a document about Anastasia.
Right.
So the AI has the husband's name, but not the death place. And since it's a one-shot system,
It's game over. It has to answer now, so it hallucinates. It might say he died in Serbia because that's where she's from. It fails because it can't perform the second hop, taking the new information, Stefan Nemanja, and starting a new search.
it lacks the ability to pivot. It can't follow the breadcrumbs.
Exactly. And the third problem is just efficiency. There have been attempts to fix this before, things like iterative retrieval, but they usually rely on really rigid rules or few-shot prompting.
Few-shot prompting is where you paste a bunch of examples into the prompt, right?
Yeah.
Here's how a smart researcher behaves. Be like this.
Yes, and that works, technically, but it is incredibly expensive. You are paying for those tokens' computing power every single time you ask a question. It makes the system slow, clunky, and costly to run at scale.
So just to recap the status quo, we have a system that is easily confused by noise, fails at multi-step logic because it only searches once, and the existing fixes are too expensive to run. I can see why they wanted a new approach.
Enter AutoRag. The authors realized that large language models, the brains of the operation, have pretty sophisticated reasoning capabilities that were being wasted by these rigid pipelines. They thought, why not train the AI to think like a human researcher?
I want to dig into that thinking aspect because thinking is a loaded word in AI. We talk about it a lot. But what does it actually look like in the architecture?
The core metaphor the paper uses is a multi-turn dialogue. But instead of chatting with a user, the AI is chatting with its tools. Imagine a conversation between two agents inside the machine. You have the LLM, which acts as the brain or the investigator, and you have the retriever, which acts like a librarian.
I like that. So the brain says, I need info on this. The librarian runs to the stacks, brings back a book, and the brain reads it.
And this is the crucial differentiator. The brain then evaluates what it read. It creates a feedback loop. It might say, thanks, librarian, but this book is about the wrong person. Go back and look for this specific date instead.
It's the difference between a student who guesses after reading one page versus a student who says, wait, this page mentions a date, but not the location. I need to go check the atlas now.
Exactly. It creates a logic loop. Look at what you know, decide what you don't know, formulate a plan, get new info, and update the plan. That is the essence of autonomous RAG. The shift here is in agency.
Agency is a big concept.
Yeah.
Usually, the human drives the search. I type the keywords.
Right. In standard RAG, the human asks the question, and the system follows a hard-coded script. Search, paste, answer. In AutoRAG, the model drives the search. The model decides if it needs to search at all, it decides when to stop, it decides if the results are garbage.
So it's less of a software pipeline and more of a decision-making engine. It feels more alive, in a way.
Correct. And that decision-making is learned, not hard-coded. That's the magic. They didn't just write a bunch of if-in statements. They taught the model to behave this way.
All right, let's get our hands dirty. I want to walk through the methodology step by step. The paper breaks this down into a very specific process that happens every time a user asks a question. Let's pretend I'm the user, I ask. Let's use a concrete example, something that sounds simple but might be tricky. When was the first Ford F-150 made?
Great example. Simple on the surface, but requires specific facts. If you get the model wrong, it might tell you when Ford was founded or when the F-Series started, which isn't the same thing. So in a standard system, it would just search that phrase. But in AutoRAG, step one is reasoning and planning.
Does it search immediately?
No. It stops. It generates a reasoning paragraph first. It's basically thinking out loud. It explicitly identifies its information needs. For your question, the model might generate text that says, to answer this, I need to know the specific launch year of the Ford F-150 model.
That seems almost redundant for a simple question. I need to know the answer to the question.
For simple questions, it feels trivial. But think about the Anastasia example. The reasoning step there is crucial. It would break it down. First, I need to identify the husband, then I need to find his death place. It sets the roadmap. It prevents the model from blindly rushing in. It forces the model to define success before it starts working.
Okay, so it has a plan. It knows what it's looking for. What's step 2?
Step 2 is the retrieval action. Based on that plan it just wrote, the model generates a specific search query. It sends this to the dense passage retriever, our librarian.
Does it just use my original question?
Ideally, no. It simplifies it or targets it. It might strip away conversational filler. If you asked, hey buddy, can you tell me when the F-150 came out? Oh, it transforms that into Ford F-150 introduction date. The librarian then comes back with the top few documents. Let's say it brings back a snippet from a history of Ford trucks.
Okay, so now the AI has some text in front of it. It has the roadmap and it has the map. Step 3.
Step 3 is information extraction and evaluation. This is where AutoRag really shines. It reads the text, but it also judges it. It asks a binary question. Does this text actually contain the answer to the specific need I identified in step 1?
It's grading the librarian's homework.
Yes. And it's a harsh grader. Let's play out a failure scenario. Let's say the retrieved document says, the Ford F-Series is a popular line of trucks that has been around for decades. It is the best-selling truck in America and has gone through many generations.
Okay, lots of facts. It mentions the F-Series, it mentions history, but no date.
Right. A standard model might see decades and hallucinate 1950 or 1948 because those are common Ford dates. But AutoRag analyzes that text and explicitly outputs a failure signal. It writes, there is no information about the specific introduction year of the F-150 in this document.
It admits defeat. That's surprisingly human. I looked, but I didn't find it.
It is. It validates the content against the plan, and that admission triggers step 4, query refinement. Since it failed, it doesn't give up. It uses the context of what failed to make a better search term. It pivots.
How does it know how to pivot? If it didn't find the answer, how does it know where to look next?
It looks at the gap. It says, I searched for Ford F-150 and got general marketing fluff. I need to be more specific. So it might change the search to Ford F-150 launch date history, or when was the F-150 added to the F-Series. It tries to narrow the scope.
And then it loops back.
Back to step 2. It hands the new query to the librarian. It says, try this instead.
Okay, let's say this time the librarian earns its keep. It brings back a document that says, the F-150 was introduced in 1975, slotted between the F-100 and F-250 to avoid certain emission restrictions.
Bingo. Now, in the evaluation step, the model sees the match. It extracts 1975. And this leads to step 5, termination.
The mission is complete.
The reasoning module confirms that all information needs are met. It stops generating queries. It then synthesizes the final answer for you. The first Ford F-150 was made in 1975.
The beauty of this seems to be the dynamic stopping. It doesn't waste time searching if the first doc was perfect, but it doesn't give up if the first doc was useless.
Efficiency and persistence, it balances both. If the answer is easy, it takes 1 step. If the answer is hard, it takes 5 steps. It adapts the compute power to the difficulty of the problem.
I want to go back to that multi-hop example, Anastasia of Serbia, because I think that really demonstrates the power of this loop for things that aren't just missing facts, but missing connections.
Yes, figure 1 in the paper. It's a perfect illustration of chaining logic.
So let's walk through it. Step 1, reasoning. The user asks, where did Anastasia of Serbia's husband die? The model thinks, I cannot answer this yet. I need an intermediate fact.
Right, I need to find the husband. So query 1 is generated. Who is Anastasia of Serbia's husband?
The librarian runs off, checks the history books, and returns a document. It says she was married to Stefan Nemanja.
Now, here's the critical moment. A standard model might just stop there and look confused because the document doesn't mention a death place. But AutoRag does the evaluation step. It says, I have the husband's name, but my original goal was the death place. Do I have the death place?
It checks the document. The document mentions the marriage, but not his death. So the evaluation is partial success.
Exactly. It updates its state. It says, okay, I have cleared the first hurdle. I know the husband is Stefan Nemanja. New goal. Where did Stefan Nemanja die?
It uses the answer from the first step to build the question for the second step. That's the hop.
That is the hop. It generates query 2. Where does Stefan Nemanja die? The librarian runs off again, comes back with a document about the Highlander Monastery.
And the model evaluates again. Do I have the location? Yes. Does it match the husband? Yes.
Final answer. Highlander Monastery.
That is incredibly satisfying logic to follow. It's like watching a detective verify a lead before moving to the next suspect.
Yeah.
It feels methodical.
And importantly, While the user only sees the final answer, the system has logged this entire chain of thought. It makes the AI's decision-making interpretable.
Right. If it gets it wrong, you don't just stare at a black box. You can look at the log and say, oh, look, in step 2, it retrieved a document about the wrong Stefan. You can audit the thought process.
Which is massive for debugging and for trust. You can see exactly where the train went off the
Now,
rails.
this all sounds fantastic in theory. It's a great flowchart. But I'm stuck on one thing. We are talking about this like it's a person following a manual, but it's a neural network. You can't just tell a standard LLM, hey, be a good researcher, be autonomous, have an inner monologue. Most models are just trained to predict the next word. How did they build this?
This is the instruction synthesis part of the paper, and honestly, it's one of the most clever parts of the engineering. You are right, there was no pre-existing data set of robots having inner monologues about research.
Robots don't naturally keep diaries. Dear diary, today I searched for cats.
Exactly, so they had to create one. They used a process called instruction synthesis. They essentially faked the data to train the real model.
Walk me through that. How do you fake research data?
They used a teacher model. Think of a very powerful, massive LLM like GPT-4 or a top-tier llama model. These giant models are already capable of reasoning if you prompt them carefully. They are expensive and slow, but they are smart.
Okay, so they have the smart teacher.
And they took existing data sets, things like natural questions, where you have a question and a known correct answer. They fed the question and the answer to the teacher model and said, don't just answer this. Show me how you would find this answer. Write out the steps, write the search queries, write the reasoning.
So they forced the teacher to role-play the auto-RAG agent. Reverse engineer the research process for me.
Yes, show your work. And they ran this simulation thousands of times. They generated massive amounts of these thought trails. But here's the catch. Even teacher models hallucinate. Sometimes the teacher went down a rabbit hole. Sometimes it reasoned poorly, but guessed the right answer by luck. Sometimes it just failed.
So you have a lot of data, but some of it is bad data. And you don't want to train the student on bad examples. If the teacher is drunk, the student learns nothing.
Precisely. So they applied filtering. They looked at the end result of the chain. If the reasoning chain led to the correct answer, the one they already knew from the dataset, they kept that data. They assumed the reasoning was likely sound.
And if it got it wrong,
If it led to the wrong answer or if the logic was circular, they threw it in the trash.
survival of the fittest data.
Exactly. They filtered out the noise. They ended up with about 10,000 high-quality reasoning-based instructions. It's effectively a textbook on how to research. Then they took a smaller, more efficient base model, specifically Llama 3.8b, and used supervised fine-tuning, SFT. They forced this smaller model to read that textbook over and over again. They trained it to mimic that specific pattern of reason, plan, retrieve, evaluate.
So they basically took a raw brain and conditioned it to have this specific reflex. When I don't know something, I will plan a search.
That's it. And that fine-tuning is why AutoRag is efficient. It doesn't need a massive novella-length prompt explaining the rules every single time it runs. It has internalized the behavior. It is the behavior.
I love that analogy. It's like muscle memory for research. The model doesn't have to think about how to research anymore. It just does it.
Exactly. It becomes second nature to the model.
But let's play devil's advocate. Every methodology has assumptions. Every system has a breaking point. I'm listening to this and thinking, okay, but what if the internet is wrong? What are the authors assuming here? What are the potential pitfalls?
Well, the biggest assumption is one we touched on. The retriever isn't perfect. In fact, the whole methodology is built around that assumption. They assume the search results might be irrelevant. That's why the evaluation step is so critical. If the model blindly trusted the retriever, the whole system would collapse.
Right. If I search Stefan Nemanja and the search engine gives me a recipe for Serbian stew, the model needs to recognize that isn't a person.
Exactly. But there's a deeper, more subtle assumption here, too. Explicit reasoning reduces hallucination. The authors operate on the belief that if you force the model to write, I found X, or I did not find Y, it makes it harder for the model to lie.
It keeps it honest. It's harder to lie when you have to show your receipts.
It creates a paper trail of logic that constrains the output. It forces the model to be consistent with itself. But there's a really interesting fallback mechanism they built in for when the internet fails completely. The parametric knowledge fallback.
Parametric knowledge, that's just the technical term for what the model already knows, right? The stuff stored in its neural weights.
Yes, it's internal memory. The authors realize there's a danger in autonomous searching. What if the answer just isn't online? or isn't in the database? Or what if the retriever is down?
The model could get stuck in an infinite loop. Search, fail, refine, search, fail, refine, forever, just
Yeah.
spinning its wheels.
Exactly, a death spiral of searching. To prevent this, they set a hard limit. Let's say $2 equals 5 iterations. If the model searches 5 times and still hasn't found the answer, the system forces a stop.
It pulls the plug on the
It
librarian.
does, okay, stop. The library is closed. And it says to the brain, you're on your own. Do you know this? The model then attempts to answer the question using only its internal memory.
That's a smart safety net. Because maybe the question is, what is the capital of France? And the search engine is broken. The model knows it's Paris. It doesn't need the search engine.
Right. It prioritizes the fresh external data because that's usually better, but keeps the internal data as a backup generator. It prevents the system from crashing or timing out.
It's pragmatic. It handles the edge cases. Now, we've been praising AutoRag, but this is a crowded field. There are other researchers trying to solve this iterative problem. The paper compares AutoRag to a few big names. One of them is SelfRag. How do they compare?
SelfRag is probably the most prominent competitor in this specific niche. The main difference is in efficiency and context. SelfRag works by retrieving a bunch of documents, and then for every single document, it generates a possible answer and a critique score.
Whoa, wait. So if it finds 10 documents, it writes 10 draft answers.
Essentially, yes. It generates multiple candidates and then compares them all to find the best one.
That sounds incredibly slow and computationally heavy. You're doing 10 times the work.
It is. But the bigger issue is conceptual. SelfRag treats each document in isolation. It ignores the relationships between documents. Remember our Anastasia husband example?
Right. Document A had the husband's name. Document B had the death place. You needed both to get the answer.
SelfRag struggles there because it tries to answer based on document A alone, fails. Then document B alone, fails. It doesn't naturally chain them together. AutoRag filters documents as it goes. It says, document A gave me a name. I'll keep that info. Now I'll use it to find document B. It builds a puzzle, whereas SelfRag tries to find one puzzle piece that has the whole picture on it.
That is a great distinction. AutoRag is cumulative. SelfRag is parallel. What about FLAIR? I've heard of FLAIR before.
FLAIR stands for Forward-Looking Active Retrieval. It's a clever idea based on confidence. As the model is writing a sentence, if it calculates that it's unsure about the next word, if the statistical probability is low, it pauses and searches.
So it searches based on vibes, basically. I feel shaky on this word. Let me check.
Pretty much. It relies on confidence scores. The critique AutoRag makes is that models can be confidently wrong. A model might be 99% sure that the capital of France is London. FLAIR wouldn't trigger a search there because the confidence is high.
Ah, the Dunning-Kruger effect for AI. It doesn't know what it doesn't know.
Exactly. AutoRag doesn't use probability scores. It uses semantic reasoning. It reads the text and understands I am missing the date. It doesn't matter how confident it feels. If the date isn't there, it searches. It's a decision based on logic, not statistics.
That seems much more robust. If I'm writing a report, I don't check a fact just because I feel nervous. I check a fact because I know I don't have the source.
Precisely. It mimics human verification standards.
And finally, there's the comparison to Iterative, or simply sticking huge prompts into GPT-4. We touched on this, but let's drive it home.
It comes down to economics. We call those methods inference heavy. If you have to feed a 2,000-word instruction manual into the model every time you ask, what's the weather? You are burning money. AutoRag is fine-tuned. The instructions are baked into the rates.
So the prompt is short.
The prompt is tiny. It's just the question. The how-to guide is already in the brain. That makes it faster and much cheaper to run per question. In the benchmarks natural questions, Trivia QA, Hotpot QA, AutoRag consistently outperformed these other methods. And notably, it was faster than SelfRag and required fewer searches than FLAIR.
It seems like they've really found a sweet spot here. They aren't just throwing more compute at the problem. They are changing the architecture of the thought process.
They are. By centering the process on the LLM decision-making capabilities rather than arbitrary rules or probabilities, they've made a system that is incredibly adaptable.
Okay, let's zoom out. We've looked at the engine, we've seen the benchmarks, we've geeked out on the training data. What does this mean for the listener? Why should they care that AutoRag exists?
I think this represents a significant step toward what we call agentic AI.
Agentic meaning acting as an agent.
Yes. We are moving away from a chatbot that just talks to an agent that acts on your behalf. AutoRag isn't just generating text, it is making decisions. It is planning. It is evaluating the quality of information. It is saying, no, that's not good enough.
It's the difference between an assistant who writes down exactly what you dictate and an assistant who says, hey, I checked that fact you mentioned and it's actually wrong. Here's the right one.
Exactly. It's a proactive partner. And the other massive benefit, which we mentioned, is interpretability.
The audit trail.
Yes. As we start using AI for more critical tasks, medical research, legal discovery, financial analysis, we cannot afford black boxes. We need to know why the AI concluded that the patient has this condition.
With AutoReg, you can see the reasoning.
Yeah.
I looked for symptoms, I found X, I ruled out Y, therefore Z.
Exactly. If it makes a mistake, you can pinpoint exactly where the logic broke down. Was it a bad search? Was it a bad evaluation? That transparency is going to be crucial if we're ever going to trust these things with important tasks.
Trust is the currency of the future with AI. Which brings me to a final, slightly provocative thought to leave our listeners with. The paper mentioned something really interesting in the analysis. They found that in some rare cases, the model actually performed worse when it searched.
Yes, this is a fascinating detail. A negative gain from retrieval.
Basically, the search results were so bad, or the internet was so full of misinformation, that it confused the model. The model's internal memory, its parametric knowledge, was actually correct. It knew the right answer. But it got bullied by the bad search results into giving the wrong answer.
It's the equivalent of knowing the answer on a test, but then looking at your neighbor's paper, seeing they wrote something else, and changing your answer to match theirs because you assume they're smarter.
Exactly. It trusted the external data more than itself, and it got burned. So here is the question. As these autonomous researchers get better and faster, are we going to reach a point where we trust their search skills more than our own intuition?
That is the danger. We are building systems that are incredibly persuasive and efficient.
And if an AI can convince itself it's wrong because of a bad search result, how do we ensure it doesn't convince us?
That is the ultimate question. We are outsourcing the verification step to the machine. If the machine is verifying itself against bad data, we might enter a feedback loop of misinformation.
Auditing their reasoning chains, checking their homework, might become the most important skill humans can have in the next decade. We might all need to become editors of AI research rather than researchers ourselves.
I think that's a very safe prediction. The role of the human shifts from finder to verifier.
Well, that's plenty to think about for one deep dive. It's a brave new world of browsing out there.
Indeed it is.
Thanks for listening, everyone. We'll catch you on the next deep dive.